Now let's look at break and continue, which are used for loop control. So let's start with an example of why you might want to do something like this. I'm going to go ahead and create a new file, PHP file called prime. And this is going to be a prime number checker. So it's going to use a value that it gets using get method. And we'll call it, I don't know, numbers good. And that'll be $ under get of number, which is a constant. And then let's check and see whether number is set or not. So if not is set, $ under get number, then we'll say we must supply a number, and we'll exit. And then let's check and see whether number is numeric or not. So now we know we have a number. Let's go ahead and check whether it's prime or not. This is not going to be a very efficient prime number checker. There's optimizations that you can pull to make this much faster, but it will illustrate the problem pretty well. So a number is prime if it's only evenly divisible by 1 or by itself. So for example, the number 5 is prime because the only thing that evenly divides 5 is the number 1 and the number 5. If you try to divide 5 by 2, you get 2.5 instead of a whole number. On the other hand, a number like 9 is not prime because if you divide 9 by 3, you get 3 with nothing left over. So 9 is not prime, but 5 is prime. So an inefficient but easy to understand way of checking whether something is a prime is by dividing it by all the numbers up to that number and seeing if any of them evenly divide the original number or not. So that might look something like this. For $candidate equal 2, because everything's divisible by 1, while $candidate is less than number, candidate plus plus. So for example, if number is 5, it will try candidate equals 2, then candidate equals 3, and then candidate equals 4. When it tries to check candidate equals 5, this is not going to be true anymore, so it's going to drop out of the loop. So if we get down here and candidate is equal to number, that means we run through all of our tests without finding something that evenly divides number. So if $number is equal to $candidate, then we're going to echo $number is prime. Otherwise, if number is not equal to candidate, that means that we found something that evenly divides the number. so the number is not prime. So how do we kick out of this loop if we find something that evenly divides number? Well, we could make this, we could put that in this test here, but that's kind of a mess. So what we're going to do instead is first we're going to see whether candidate evenly divides number, and then if it does, we're going to kick out of this loop right then. So if, and here's how you check to see whether, actually I should have a space here. I've been not so good about including the spaces here because I usually don't. But we're going to use the mod function in order to determine whether candidate evenly divides number or not. So if $number mod candidate is equals 0, that means that candidate evenly divides number. So for example, 4 mod 2 is 0 because 4 divided by 2 is 2 with 0 left over. 5 mod 2 is 1 because 5 divided by 2 is 2 with 1 left over. So if number mod candidate is equal to 0, then we know that candidate evenly divides number, and we want to break out of this loop and continue with the if statement. So to break out, we just say break. Like so. So break is going to break out of whatever loop it's currently inside of. If is not a loop, so it doesn't break out of the if statement, it breaks out of the loop that the if is inside of. So let's go ahead and test it and see if this works. So I'm going to go to my primes.php page, and I haven't supplied any values. Oops, I think I just called it prime. So I must supply a number, and let's give it something that isn't a number. A numeric value must be supplied for number. I forgot my exit statement here, so let me exit. Great. So now let's try a number that is prime, 5. So 5 is prime. Let's try a number that isn't prime, 6. 6 is not prime. One more. So 7 should be prime, and it is. 8, not prime. 9, not prime. So the good thing about break here is that I'm saving the value of candidate, and so I can check it down here. But also it makes the code a lot more efficient. For example, if I was to check whether number is 100,000, it does that right away, and the reason is because 100,000 is divided by 2, so we know on the first check that we're done, instead of having to loop through all the other candidates. So what about continue? Well, let me go ahead and copy this and paste in a new one and call this one primes. So what this one is going to do is it's going to go from 2 all the way up to number, and it's going to check each of the numbers in that range to see whether they're prime or not. And if it's prime, it's going to output it, and if it's not prime, it's just going to skip it. So all of this is the same because we want to make sure that the user's entered a number. But then here what we're going to do is we're going to have a nested loop. So this first loop here is going to go through all my potential primes, and let's just call this P. So P is equal to 2, P is less than or equal to number, P plus plus. And then I'm going to put my prime check inside the loop here. And then, instead of checking whether number is prime, now I'm going to check whether P is prime. So if I hit this break statement, I know that P is not prime. If I get all the way to the end of the loop, down here, I know that P is prime. So let's go ahead and move this statement, P is prime, up here. And then instead of break, let's start by moving this line here. But this is not going to quite do what I want it to do. So let's see what it actually does with this $P. And then I also have to change this right here so that it outputs P. So let's go ahead and try this. It's not quite right yet, but let's see what it does. So we'll generate the primes up to 100. So 2 is prime, that's right. 3 is prime, that's right. 4 is not prime, that's right. But then it goes on and it says 4 is prime. So 5 is prime, and then it says 6 is not prime because 6 is divisible by 2. And then it says 6 is not prime again because 6 is divisible by 3. And then it says 6 is prime. So let's look at what's going on. So every time it finds a candidate that evenly divides P, it outputs P is not prime. But then if there are multiple factors, numbers that evenly divide P, it's going to output one of these lines for each of those factors. And then when it exits the loop, it's also going to output P is prime here. So what we want to do, we could try to fix the first problem by putting this break back in. So now when we first find the first candidate number, it's going to break out of this for loop, and so it'll only output P is not prime once. So that'll solve one of our problems. Instead of saying 6 is not prime twice, it'll just say 6 is not prime once, like so, right? Because it kicks out after the first factor. But then it's still saying 6 is prime here. So what we really want to do is, instead of breaking out of this loop, we really want to continue this loop with the next value, right? So instead of just breaking out of this loop and then going to the next line, what we want to do is jump back to this loop and take the next value of P. And so that's what continue does. So continue is going to continue this loop, which is not really what we want. We actually want to continue this loop instead. So with both continue and break, you can also put a level. So continue to means that I'm going to continue the second loop. So I'm inside the first loop. I'm also inside the second loop. And continue to is going to jump back up here in the second loop and take the next value. So let's go ahead and see it, if it works, and it does. So 2 is prime, 3 is prime, 4 is not prime, 5 is prime, 6 is not prime rather, 7, 8 is not prime, 9 is not prime, 10 is not prime, 11 is prime, all the way up to 100. So 97 should be the last prime number less than 100. So this is actually doing what we want it to do, because when it finds the first factor, it jumps back up to here, takes the next value of P. If it doesn't find any factors at all, then it echoes that P is prime. So that might be a little confusing, but if you think about it for a while, you can actually trace through it as well. So let's actually trace through it and see what's going on. I'm going to enable debugging, and I'm going to put a breakpoint right here, and then I'm going to hit reload. And so what I want to do is, if you get a little pop-up that says, if you want to map the path, just go ahead and say yes. But so I'm going to continue execution until P gets to be 6. So 2, 3, 4, 5, 6. Oh, there's 6. So 6, I'm going to step in, so 6 candidate 2, 6 mod 2 is 0, so I output that line, then I hit continue 2, jumps me back up to this line here, which sets P equal to 7. So it executed this part of that line. Now P is 7. And then we check P mod 2, no. P mod 3, no. P mod 4, no. 5, 6. And now candidate is 7. 7 is not less than P, so we should drop down to the next statement. And we echo 7 is prime. Return back up to this one. P is now 8. Then we check whether P is less than or equal to number. It is. So we loop through our next set of candidates. So here we got 8 was divisible by 2, so we continue back up to here. So as I said, it takes a little practice getting used to that, and you don't always need it, but sometimes it can make your code more efficient and more concise.